So we already started talking about what the real numbers are. We're going to focus a little bit more on irrational numbers. I'm going to go back over the real number system again. Remember, you have natural numbers, otherwise known as counting numbers. These are 1, 2, 3, 107, doesn't matter as long as you count them normally. Let's see here. Oh, what else can be under here we haven't talked about? It's like the square root of 4, because the square root of 4 is 2, and 2 is a counting number, so that counts. But we'll get more into square roots later. Whole numbers is your next one. Whole numbers are all your counting numbers and 0. So we're adding 0 to this. Because remember, 0 is a whole lot of nothing, right? It still counts as a number. Okay, next one is integers. Integers are all natural numbers and whole numbers, so it encompasses all this, and their opposites. So whole numbers and the opposites. So 5, -5, -10, -102, -97. Doesn't matter. It's all those negative numbers that go with those positives. And last but not least that we've gone over are rational numbers. Rational numbers are numbers that can be defined as fractions. So in here we have like 4/5, -7/8, 0.075, because 0.75 is 3/4. 31.8. Okay, so we're going to define this a little bit more. So rational numbers are all numbers that can be expressed or that have that. Let's redo that. So rational numbers are numbers that can be expressed as a fraction. Remember, 2 or 5 can be represented as a fraction because 5 is, remember we've talked about, it's just 5/1. All right. If it is a decimal, the decimals are repeating. So it's in repeating in nature with pattern, in their pattern, like 7, 8, 7, 8, 7, 8, and keep going like that, or terminating. So terminating like 0.8, 0.75, those are terminating. 0.125, doesn't matter. Okay, integers. Integers are whole numbers and their opposites. Also remember rational numbers, so they're all integers, positive and negative, fraction and whole number. Okay? Whole numbers. All counting numbers and 0. Natural numbers are counting numbers. Okay, irrational numbers. So irrational, easy way to remember this, is opposite of being rational. So if it is an irrational number, it cannot be represented as a fraction. So cannot be represented as a fraction. So that means when it comes to decimals, if A rational number is repeating or terminating. Decimal is non-repeating and non-terminating. So the first one, so I'm going to put irrational right here. Put an irrational outside because this all encompasses rational in here. We don't go over a lot in pi this year, but pi is 3.1475, like blah, 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 blah. The number goes on. It's non-repeating, non-terminating. So that means the numbers don't repeat in any fashion. There's no rhythm to it, and the number goes on forever. So this could also include numbers like 7, 8, 2, 4, 7, 6, 5, dot, dot, dot. If you notice, there's no pattern to it, and it keeps going and going and going. Other things that you will see here are like the square root, like 7. Square root of 7, we haven't gone over that yet, but is not a whole number or a terminating decimal, so therefore it is irrational. I put square root of 4 under natural number because the square root of 4 is 2. It is a whole number that you count. Other numbers you can put here is like a negative square root of a number. That is not a perfect square. I have 1.12.112.1112. There's a pattern, but it's not repeating. Okay. Go ahead and try it if you want to. Otherwise, I'm just going to do the try it so you can see how it's done. Classify each number as rational or irrational. So pi, we already discussed that up here at top. It is irrational. So I'm going to put it right there. Okay, this number 3.565565556 may have a pattern, but it's not a repeating pattern. So that one also goes here. 0.76 repeating. It is a repeating, non-terminating decimal, so it is rational. 3.275, it is terminating because it stops, so it is rational. All whole numbers, positive or negative, are always going to be rational. And last but not least, 0.0405030661, that is going to go right here. Because it is non-terminating by the dot, dot, dot here. And there's no pattern to it. Okay. Or it's non-repeating, non-terminating. All right. Next page, example 2. Identify square roots as rational or irrational. So, what is a square? A square is a number that you're multiplying by itself. So a perfect square, so a square is a number times itself. If I have that definition right, but that's okay. We're going to move on from that. A square root is the opposite. So if I have 2 times 2, that is a square because a repetitive number multiplied by itself, I'm going to put that number here, the base, that's the multiplier, and the number up here is my power. That's square. I'm multiplying it by itself 2 times. A square is a number multiplied by itself 2 times. Okay? All right. A square root of a number is that a number that is multiplied by itself equals the original number. So, if I had the square root of 7, let me just rewrite the definition first. A number that when multiplied by itself equals the original number. And we use the symbol, the radical symbol, of this to represent square root. Okay, and it has to be non-negative. So 1.5 times 1.5 would be not a perfect square, which we're going to go over in a minute. But 1.5 times 1.5 is 2.25. So if I took the square root of 2.25, I would get 1.5. So you can have, so if I classify this number, 1.5 is a rational number because it's terminating and non-repeating. Next thing we're going to look at is perfect squares. A perfect square, that's a number of a square that is an integer. So a perfect square is a number that is the square of an integer. So what that means, a perfect square, I'm going to translate, it's going to turn out to be a whole number. So I'm going to use this to kind of show it. I'm going to fill in this one box. We're going to look at length times width. We've already done that sum to share. I have a length of 1 and a width of 1, so it's 1 times 1 is equal to 1. The square root of 1 is 1. Next one we're going to do, remember they're going to have to be the same length and width. So that's not going to be a perfect square because it's a 2 by 1. I'm going to go until I have a square. So all perfect squares, if you draw them out, will look like a square. I have a 2 by 2. 2 times 2 is equal to 4. The square root of 4 is going to be 2. So I have 2 on either side. Okay, next one. Okay, you notice I have 3 across and 3 up. 3 times 3 is 9. So the square root of 9, I have 3 in either direction, will be 3. So if you look here, I went 1, 2, 3 when I went from what I was multiplying, 1, 2, 3. But if you look at their square roots, or their squares, I went 1, 4, 9. 2 is not a perfect square because if you noticed, if I only did 2, it doesn't make a square. We have a length of 1 and a width of 2, or vice versa. Same with 3. We went from 1, 4 to 9, so 3 would just be 3 one way. It won't make that perfect square. So we're going to write down our perfect squares in a minute. So general rule is for any whole number, I'm going to say that's going to be represented by a B, that is not a perfect square, the square root of that number is irrational. So your only rational square roots of whole numbers will be perfect squares. So square root of 23. Here, I'm going to help you out here with this first. I'm going to write our perfect squares to know. So 1 times 1 is 1. There's a perfect square. 2 times 2 is 4. So it's any whole number multiplied by itself. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. And 12 times 12 is 144. There are way more than that. As long as I can multiply the same number by itself, doesn't matter how big or how small, they're going to keep going. Okay. So you can always find these. I'm going to go back to the try it now. Square root of 23. I'm going to look at this list. I go from 16 to 25. These are perfect squares. 23 is between 16 and 25, so it is going to be irrational because 23 is not a perfect square. Square root of 25, I'm going to go up the list. There's 25 right there. That means it's going to be rational. Square root of 25 is 1, 2, 3, 4, 5. If you look at a multiplication chart, the wonderful square where you have 1 times 1 and then whoop, 2 times 2, your perfect squares are going to be along this diagonal line right here. Okay? Kind of looks like a flag the way I drew it. Okay. Square root of 100, I'm going to go up this line right here. And square root of 8, it goes from 4 to 9. So square root of 8 is irrational. Right. Example 3. Classify each number as rational or irrational. Explain how you classified each number. So this just gets a little bit more in depth. I'm going to look at this first one. It is a whole number. Positive or negative, it is a whole number. So therefore, it is because it can be represented as a fraction. Because all whole numbers can be represented as a fraction. Square root of 11. If I go back to my chart, it's between 9 and 16. It is not a perfect square. Any number times itself will not be 11. So my explanation is it's an imperfect square. Imperfect meaning the square root is a decimal, not a whole number. Okay, next one. I did those. 5.636336333. Okay, it has a pattern. It's not repeating and it's not terminating. Therefore, it is irrational, non-repeating, non-terminating. Okay. And square root of 16. I'm going to go back to my lovely list. This is a list you're going to want to have. 16 is on my list. So therefore, the square root of 16 is perfect. Therefore, it is rational. All right, go ahead and try to do the try it by yourself. Pause the video if you like, or just watch it for more examples. 2/3. 2/3, it's a fraction. Because all fractions are rational. Square root of 25. 5 times 5 is 25. So that means the square root of 25 is 5. So it's a perfect square. 0.75 repeating. Oh, it's starting to look like they all. Square root of 2. 2 is not a perfect square. Okay, whole number. Just going to put a fraction because I can represent it as a fraction in this last one. 2769409. It is non-repeating, non-terminating. All right. That is it for notes. Please let me know if you have any questions.